Welcome to today's mini lesson. Today is part 2 of empirical formulas. So what we're going to concentrate on today is distinguishing the difference between an empirical formula and a molecular formula. So I'm using your notes, so you can just follow along with me in your notes. Fill these out on your own paper. At the end, take a pic and then post them into your notebook. So empirical formula versus molecular formula. So far we've just been talking about formulas. So what's the difference between the two? Well, if you can look at these, you can obviously see they have the exact same elements present. They have different ratios or different mole values. But if you look at this one, this is at a 1 to 2 to 1 ratio. It cannot be reduced down anymore. It's in its lowest forms. That's an empirical formula. Whereas if I look at this one, you see how I have a 6 to 12 to 6 ratio. Well, that's going to reduce down to that 1 to 2 to 1 ratio. Since it can be reduced down and it's not in its most reduced form, then we're going to call this the molecular formula. So molecular formulas can be reduced down. Empirical formulas cannot. Now, what's really neat about this, and we talked about the ratio of masses and how they stay the same based upon the mole-mole ratio. Well, this is a 1 to 2 to 1 mole ratio. This is a 1 to 2 to 1 mole-mole ratio. So let's go through and look at something. If I told you that one carbon, 2 hydrogens, and 1 oxygen had a molar mass of 30, I'm not going to work it all the way out. I'm just going to tell you that. And then if I said 6 carbons, 12 hydrogens, and 6 oxygens has a molar mass of 180. You say, well, what does that mean? Well, if I compare these two and I divide them out, 180 divided by 30, that's the molecular mass over the empirical mass, then I'm going to get 6. That 6 is the factor or the multiple that my molecular formula is to my empirical formula. So if I distributed that 6, I would get 6 of those, 12 of those, 6 of those. And that's exactly what I have. So just put that in your brain storage warehouse for just a minute. We're going to come back to it. But before we do that, I want to go through and show you a typical molecular formula problem. So number 4, example problem 4 says, what is the molecular formula for a compound with a molar mass of 152.04 and the percent composition is 39.9 and 63.1? Guys, this is the exact problem that we did in the first mini lecture on formulas. So we're not going to change anything. We're going to say, okay, if I know that I am given 152.04, I'm going to multiply that by my 36.9% of nitrogen, and that will tell me how many grams of nitrogen would be contributed. And I'm going to get 56.10. So I'm going to put 56.10 grams of nitrogen. I'm going to do the same thing with my oxygen. I'm going to say 152.04, and then I'm going to multiply that by 0.631. When I do that, I'm going to get a value that is 95.94. So I got 95.94 grams of oxygen. So if I wanted to see how many atoms of nitrogen that would take, I would just simply divide it by the mass of one nitrogen atom, which is 14.0. When I do that, I'm going to get a value of 4. And then when I do the same thing over here and I say 95.94 divided by 16.0, I'm going to get a value of 6. So did we do anything different from the way that we did it the last time? No, we did not. Same video, everything is exactly the same, but when I write it out, you'll notice that it's N4O6, which means that is its molecular formula because it's not in its most reduced form. So is there any difference? No. You just have to identify whether or not it's reduced or not reduced. If it's not reduced, we call it the molecular formula. If it is in its most reduced forms, then we call it the empirical formula. All right, so let's look at the second problem. The second problem that we do here, example 5, is very similar to what we did up here when we were comparing. So it says, what is the molecular formula for a compound? So ding, 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 that's telling me molecular formula, non-reduced, with a molar mass of 228.06 grams per mole and an empirical formula of N2O3. Now guys, there's a lot of different ways that you can do this. We could do it exactly like this, except I don't have my percent compositions. But if I wanted to, I could say, okay, well, if I know the formula, I can go back in, get part divided by whole, get its percentages, then do it exactly like the first one. But there is an easier way if you realize this. Do you remember up here I told you that we can determine our empirical mass and our molecular mass? The multiple of our molecular mass to our empirical mass tells me what the multiple of the molecular formula is going to be. So what I can do instead is I can just simply say, let's do it like this, N2O3. What is the mass of this? In order to do it, I'd say I have 2 nitrogens. That's going to be 14.0 for a total of 28.0. I have 3 oxygens at 16.0 for a total of 48.0. So now I'm going to add the two together. I get 0, there's a 6, 76.0 is my empirical mass. So if I wanted to find out what the multiple was, I'd just take my molecular mass, 228.06. I'm going to divide that by 76.0. I'm going to punch that in on my calculator, and when I do that, I come up with 2.998. So that's definitely rounds off to be a 3. So this means that my molecular formula is a multiple of 3 of my empirical formula. You say, so what does that mean? Take my empirical formula here, N2O3, and distribute a 3 throughout it. So I say 3 times 2 is 6, and 3 times 3 is 9. So that is going to be my molecular formula for the second type of problem. So I hope that this has helped you. Again, you're going to go through, fill these example problems out on your own paper, post them into your notebooks. But the big thing is realize that we're really not doing anything that we haven't already learned. We're just calling it a different name. If it's reduced, it's the empirical formula. If it's non-reduced, it's the molecular formula. I hope this has helped you. Thank you.